So here are the answers to your warm-up. The first question is, what is net force? Net force is the total or result of all the forces that are acting on one object. The unit for force is newtons, named after Sir Isaac Newton. According to this diagram right here, the net force on this object is 20 newtons to the left. Since these two forces are acting in the same direction, we add the forces together, and we also give a size, 20 newtons, but we also give a direction. This last picture may be covered up on my webcam, but you should have done your warm-up already. So according to the diagram, the net force on the last object for your warm-up is 0 newtons. There will be no motion. Since the forces are acting in opposite directions, we subtract, and since they're the same size, 9 newtons minus 9 newtons would be 0 newtons. I want to add one more warm-up question, so stay on your warm-up. If you're not there, go back to your warm-up. One more warm-up question is this. Let's say the two guys are helping each other out. Huey and Louie are both moving a dresser together. They're both pushing on this dresser on the same side, but Huey is pushing with a force of 100 newtons, and Louie is pushing with a force of 200 newtons. Now, I pulled this picture up off the internet, but if I was going to sketch this, I would just draw a box, 2 stick figures, one vector arrow that's smaller than another vector arrow, and then I would label the 2 vector arrows. So this one right here I would label with 100 newtons, and this one right here would be labeled with a force of 200 newtons. When you're drawing force vectors with the size, always include the unit with your vector arrow right above it. So you have the size of the arrow plus the direction of the arrow. So obviously, since these guys are working in opposite directions, since these guys are acting in the same direction, we would add their 2 forces together, and so their combined forces, or net force, is 300 newtons, because 200 newtons plus 100 newtons is 300 newtons. Please add a quick sketch of this problem, plus the vector arrows, plus the answer to your warm-up. Just as a quick review, from yesterday you learned that to find net force, if the forces are acting in the same direction, you would add them, and if the forces are acting in opposite directions, you would subtract them because they are working against each other. But there will be some cases where there will be more than 2 forces. In this case, you would still add forces that are acting in the same direction and then subtract forces if they're acting in opposite directions. In this case, even though there's more than 2 forces, 5 newtons plus 5 newtons is 10 newtons going against another 10 newtons, so the total or net force on this case would be 0 newtons. So this is one of your assignments today. I want you to start with this side of your assignment, finding net force. I'm going to do the first one with you, and then you are on your own for the rest, OP and IP. Let's say you have 2 athletes that push on the same side of a practice dummy. So I'm going to make just a quick sketch. Here's a practice dummy, right? So imagine these 2 guys are playing football and they're pushing on a practice dummy, right? So I've got 2 athletes and they're pushing on the same side. So they're both going the same direction. One athlete exerts a force of 240 newtons to the right. So I draw a vector arrow and label it 240 N. I know mine's kind of sloppy because I'm doing this with my cursor. The other athlete exerts a force of 290 newtons to the right. So 290, label your vector and use your units. What is the net force acting on the dummy? Well, in this case, we would add these 2 forces together. What I want to see then is the total net force, and I want to know which direction the object is going to move. Is it going to move to the right or to the left? Now, if an object is not going anywhere, you would just say 2 newtons to the, and if you want to just shorthand it up, you just say 0. It's not going to go anywhere. So I want you guys to do the rest of this on your own, finding net force for OP, and also finding and calculating net force for IP. When you do the IP side, don't forget to justify how you got your net forces and show me your motion vector, the 2-tailed arrow, showing me which direction the object is going to move.